This video covers how to troubleshoot non-working or some pixels not working on an AlphaPix Evolution CPU. Step 1. Separate the controller from the application. We never want to test using an application. We always want to test using the built-in test mode on the controller. Why that is important is that this takes away all the layers above the controller. The networking cable, the network configuration, the network on the computer or on the console, or misconfiguration of the console or software that you're running. So, by testing using the built-in test mode, we will know if the data coming from the controller directly by itself will make the lights light up. If we were able to make the lights work from the controller, we know that the light issue is not with the physical light or the physical controller, but something in the application or above the controller's configuration. So, let's focus on testing at the controller level. The first step in troubleshooting is making sure that your controller is properly configured. Go into the web interface and ensure that your controller has the proper number of pixels configured for the port or output you're testing. For example, in this case, we have a pre-built controller and it is using output 33, and we have a string of lights connected to it. Now, it's important to understand that the controller's test mode will only normally, using the built-in test mode on the button interface, which we'll show you in a moment, configured pixels only. In other words, if the controller is configured to output to, let's say, 50 pixels, and you hook up 100 pixels, you should expect only 50 pixels will light up. 100 will not light up. Now, you can see our other videos on how to go into the controller and use the all pixels option through the web interface to test all pixels no matter how many pixels are connected and bypass the configured pixels option. We will assume that you have properly configured your controller so that the outputs, in this case 33, has the appropriate number of pixels configured. Now, in this case, we have a default controller, which is by configuration set up to output to 170 pixels. Now, in this case, we only have 50 pixels connected to this controller. So, let's get started. Now, what we're going to do is put the controller into test mode by pressing and holding down the M button, mode button. This enters test mode and the lights go off. I'm just going to show you one pixel here, and you can see that they're off. I'm going to hit the plus sign, as it's saying here, to select the particular mode. And we can see that the color is red. Now, normally, if your controller and your pixels are configured correctly, because you can configure the color order in the controller, see our other videos. In this particular case, this is an RGB pixel. The controller defaults to RGB pixels, so it shows up properly. We select red, the pixel is red. We select green, the pixel is green, or vice versa. Now, we can go in and also select white. White is very useful for doing burn-in testing, but also for checking to make sure that you do not have power issues. If you select white, that means that all the pixels are operating at full output for all colors. You have red, green, and blue, and thus, if you experience issues where your pixels are turning yellow or brown, that indicates you may have a power issue and your pixels are not properly configured or constructed. Now, in this particular case, we do have the pixel, and you can see that it is turning on. We can even do a red, green, blue test chase. Now, here are the possible issues. In this particular case, all the pixels are working correctly. Everything seems fine. Let's say that the pixels do not turn on at all. No response happens. The first step is to go to another output. So, let's say you pick output 35. You would take the lights and just move them from this output 33 to 35. And what we're doing is we're doing A/B testing. We're checking to see if the problem is with a specific output or the specific lights. Now, in this particular case, our lights continue to work. Well, let's use an example. Let's say that when they were hooked up to output 33, they were not working. But when I hook them up to output 35, they start working. That tells you that there's a problem with the output 33, not with the lights, because the lights work when they move to a output that is fully functional. So, if it's not working on output 33, we need to figure out why output 33 is not working. Now, this could be a variety of reasons. One is it could be the fuses. Now, not shown here, there are fuses down at the bottom down here. This particular controller has poly fuses. That means that the fuses are set and triggered if you short them out for a period of about 5 minutes, and then they will turn off. There is a mode in the controller, and we can go ahead and take it out of this test mode and let it go through its test regular mode, its idle screen, and we will see once we get to this here. There's the voltage, there's the temperature, and there is SPI fuse state. I'm just holding the center button to pause the screen, and we can see that the SPI, which is the direct connection, now differentials don't have fuses, but SPIs do. All of them are okay. None of the fuses are showing blown. This is on the current most modern board that we sell. If you have a legacy board, it may have physical fuses. In those particular cases, there are actually lights next to each fuse. If a red light is turned off, that means the fuse is blown. So you should see on a normal board all red lights. Now, if you should have a long range, and this board does have a long range, your long range board functions exactly the same as in a regular SPI output. You would just need to go to the long range and test from there. All right, so what did we find when we tested that? All right, well, let's say that we determined, hey, output 33 doesn't have a blown fuse. It's okay, right? Now, what do we do next? Well, could it be something else? Could it be the cable? Now, rarely do we have problems with the actual cables, so it could be a problem with the connections in the cable. So down here at the bottom, depending upon the configuration of your particular controller, you will see that there are connections here. And these are push to connect connections. Yours may have screw type terminals, so they may have come loose. This is the most modern version, and these generally cannot come loose if factory installed. But if you've built this yourself, maybe you have a wrong or loose connector. Also, our controllers generally always have a color coding system, and you can see that the wires are red, yellow, and black, and they're all in the right spot. I should also note that you can see down here at the bottom that there are the, let me see if I can move these out of the way here. You can see that there's a 9/25/41. That is the connection for the specific cable. And this is because the board could be either in the 9 position, the 25 position, or the 41, depending upon which expansion board it is. So that also allows you to figure out where this particular board is on that specific output. All right, so if we've now checked the connection here and we've confirmed that first, we didn't have a fuse problem, everything is fine, and we check this connection here, make sure that our cable is fully seated. You might even give all the wires a little bit of a tug to make sure that they're absolutely stuck in there. You can move the cables from one output to the next output. So, for example, let's say that we have a cable here that's not functioning, but this one is functioning. You could unhook this connection and move it over here and see if the problem follows the cable or if it follows the output. Now, if you move the cables around and the output still continues not to work, we know that likely the problem is not on this individual board or connection. And it, in fact, may be further up in the ribbon cable, because each one of these wires in here comes from the bottom board and feeds the ribbon cable that goes down to the board from the CPU. Now, you can go in and you can reseat this. You never want to remove these ribbon cables while the controller is powered on. Always power off the controller. And in this particular case, we'll go ahead and just unplug the power. And we can go ahead and pop these levers forward and lift the ribbon cable out of place. And if you saw any kind of misconnection or anything like that, that would be an indication that there's a problem. And then we can just reseat it. Make sure that these hooks that hold the cable into place are fully seated. Now, if you then turn it back on, again, you can go through that process of swapping the cables around to make sure that the problem is either with the pixels or the output by doing the swapping. So, one of the key takeaways from troubleshooting is take something that works and swap it with something that does not work. So again, if you have pixels that don't work on one output, move them to a known good working output. That'll allow you to isolate. Is it the pixels that's the problem, or is it the controller that's the problem, or even the expansion board? So hopefully this has been helpful. If you ever have any additional problems and this troubleshooting did not solve them for you, please feel free to reach out to us at HolidayCoro.com/contact us.